All right, given two strings, x and y, find the length of the longest common substring. So if we had an input of A, B, C, D, X, Y, and Z, and then we also had X, Y, Z, A, B, C, D, then our output would be 4 because A, B, C, D is the longest substring in these two strings that are in common. So to tackle this, we're going to use dynamic programming, which will give us an m times n solution. All right, and so how it's going to work, we're going to just chart this out just so that we can be organized about it. We'll have zeros for the start, and then A, B, C, D, X, Y, Z, and X, Y, Z, A, B, C, and D. Okay, and we'll just make a grid. Okay, so what we'll do is everything in the first row and the first column is zeros, kind of our base. Okay, and then we go in and we look at each element against each other. So if we look at X and A, and actually let's go ahead and label this all. So what we would do is X equal to A, it's not, so it gets a 0. Is X equal to B, it's not, we get a 0. Is X equal to C, it's not, we get a 0. Is X equal to D, it's not, we get a 0. Is X equal to X, yes, so it's 1. And is X equal to Y, no. Is X equal to Z, no. Okay, now we go here, is Y equal to A? No. Is Y equal to B? No. Is Y equal to C? No. Is Y equal to D? No. Is Y equal to X? No. Is Y equal to Y? Yes. So we look at the diagonal, which is 1, and we add 1. So it's 2. Is Y equal to Z? No. Okay, and then we go to Z. Is Z equal to A? No. Is Z equal to B? No. Is Z equal to C? No. Is Z equal to D? No. Is Z equal to X? No. Is Z equal to Y? No. Is Z equal to Z? Yes. So we look at the diagonal, which is 2, and we add 1 to it, so that's 3. And at this, as we're going, we'll store the maximum as we get a new max. And then we go here to A. Is A equal to A? Yes. We look at our diagonal, we add 1. AB, no. AC, no. AD, no. AX, no. AY, no. AZ, no. And then we go to B. B and A, no. B and B, yes. Add 1 to the diagonal. B and C, no. B and D, no. B and X, no. B and Y, no. And B and Z, no. We go to C. C and A, no. C and B, no. C and C, yes. Add 1. We get 3. C and D, no. C and X, no. C and Y, no. C and Z, no. Then we go to the D. D and A, no. D and B, no. D and C, no. D and D, yes. Add 1 to the diagonal, that's 4. D and X, no. DY, no. DZ, no. Okay, and then we can look that and see that the maximum we have is 4, which is what we were looking for A, B, C, D as the common, so we would return that 4. So let's go ahead and code this. All right, so we can have a function public, and it will return the length of the longest sub, get length. Actually, let's get longest substring, and it's going to take string 1 and string 2. Okay, so we're going to want to have a max variable to keep track of our maximum value as we go. And we're going to need to make our 2D array to store our answers in. So we've got int 2D array. We'll just call it array, and that can equal new int, and it's going to be string 1 dot length plus 1, because we're adding that extra first elements on, and then string 2 dot length plus 1. Okay, we've got that, and then we will work to fill the matrix. So for int I equals 0, I is less than string 1 dot length I plus plus. Okay, and then we've got for int j equals 0, j is less than string 2 dot length. Actually, we have to do less than or equal to, because we have that extra that extra element on the beginning of both the column and the row for those extra zeros. So I plus plus. Okay, so first we want to fill up the zeros. If I equals 0 or j equals 0, then we know that we want array at ij to equal 0, and that'll fill up those the first column and the first row with all zeros. Else if string 1 at I minus 1 equals string 2 at I minus 1, mean at j minus 1, then we know that array at ij is going to equal, when they're equal, we're doing the diagonal plus 1. So array at I minus 1, j minus 1, plus 1. Else they're not equal, and in that case, we get array at ij equals 0. Okay, and then after that all, we can calculate our max based on whatever I and j ended up being. So max equals math dot max of max and array at ij. And then at the very end, we finish this for loop, we finish our other for loop, and then we return max. Okay. All right, so let's go ahead and run through this. Actually, get an example. Okay, so let's say our example is B, A, X, Y, Z, E, F, and string 2 is A, B, X, Y, Z, F, E. So we're looking for 3 to be our answer. So we'll just make a note of that. Okay, so if we draw our matrix, okay, let's see if we can rotate that. Let's just do it again. Draw our matrix. Okay, and we've got to do zeros to start, and then we get B, A, X, Y, Z, E, and F. Then we get A, B, X, Y, Z, F, and E. Okay. All right. And so we go in and we can keep track of I and J and Max. Okay. So we go in, we've set up our array, and it's of length, the string length plus 1, because it's 1, 2, 3, 4, 5, 6, 7, 8, and our string length is 1, 2, 3, 4, 5, 6, 7. So we've set up our array the way we want at length plus 1 by length plus 1. Okay, so I starts at 0, and we'll go ahead and make a note of that is 7. This is 7, and J starts at 0. Okay, so if I equals 0 or J equals 0, well, they both equal 0, then array at IJ. So, and actually, let's just number these really quick. Okay, so array at 0, 0 is 0. Okay, then we go in, we skip everything else. Max is still 0. And then we go in and J plus plus. So J is now 1. And we go in if J equals 0 or I equals 0. Well, I still equals 0. So array at 0, 1 is 0. So we go in, J plus, J is now 2, 2, 0. We know that all of these are going to hit. Until J gets to 7, and 7 goes through, and then we get that, and we know that we go through, and J, or then we do I plus plus because we went through all the J's. Now I is 1, J is back to 0. So if I is 1, J is 0, we get 0. J plus plus, J is now 1. If string 1 at I minus 1, so 0, let's number these. just so we can stay organized. Okay, so if A and B are equal, we would look at the diagonal, but we're not, so it's 0. Math.max is still 0, j++. At 1 and 2, if they're equal, which they are, then array at ij, which is array at 1, 2, equals array at I minus 1, j minus 1, plus 1. So that's a 1. Go in, max is now 1, j++. Okay, so we look at A and X, and they are not equal. So we go to array at ij equals 0. Math.max is still 1, j++, j is now 4, 4 is less than 7. And we get in there, and it looks at A and Y, 1 and 4. And got A and Y, so we've got 0. And then max is still 1. Okay, j++, j is now 5. 5 is less than 7. Go in, A and Z are not the same. We get 0, max is still 1, j++. A and E, 0, j++, j is now 7. A and F, 0, j++, j is 8. 8 is not less than or equal to 7, so we get out of that, and we can do an I++. I is now 2. J goes back to 0. So now we get here j equals 0, so we get a 0 here. J++. Okay, now we go in and we look at B and B, which are equal. So array at ij, so array at 2, 1 equals array at I minus 1, j minus 1 plus 1. So that would be here. And so we're looking at it being 1. Okay. Math.max is still 1, j++. Now we're at 2. We look at B and A. They are not equal. That's a 0. Max stays 1, j++. J is 3. We look at B and X. They're not equal. Max is still 1, j++. J is now 4. B and Y, 0. Max is still 1, j++. J is now 5. 5 is less than 7, so go in. We look at B and Z. They're not equal. Max is still 1, j++. J is now 6. We look at B and E. 0. Max is still 1, j++. J is now 7, so we look at B and F. 0. J is now 8. Max is still 1. J is not less than or equal to 7, so now I++. Oops. I++. J is back to 0. We get a 0 in this first column. Then if string 1 at I minus 1, string 2 at j minus 1, so if X is not equal to B, which it's not, we get a 0. And max stays 1. J++. X and A, they're not equal. Max stays the same. J++. X and X, they are equal. So we look at the diagonal. We add 1. And max is still 1. J++. 3 is less than or equal to 7. So we keep going. And if X and Y are equal, which they're not, max is still 1. J++. Now if X and Z are equal, they're not. max is still 1, j plus plus, x and e is 0, max is still 1, j plus plus, x and f, oops, I think I forgot to increase that, x and f are not equal, put a 0, max is still 1, j plus plus, now j is greater than 7, so we get out of that, I plus plus, I is now 4, j is back to 0, max is still 1. We get in there, and first we know that j is a 0, so we put a 0 here, and then max is still 1, j is now 1, we put a, we look at y and b, which is 4 and 1. We look at y and b, and we've got 0. They're not the same. Max is still 1. J plus plus. Y and a, 0. Max is the same. J plus plus. Y and x, 0. Max is the same. J plus plus. Y and y, that's equal. So we look at the diagonal. And it is array at ij equals array at I minus 1, j minus 1 plus 1. We get 2. Max is now 2. And j plus plus, y and z, they are not equal. Max is still 2. J is now 6. Y and e are not equal. Max is still 2. J is now 7. And y and f are not equal. So max is still 2. J is now 8. 8 gets us out of that for loop. So I plus plus. Now j is 0. And we go in. And since j is 0, we put a 0 here. Max is still 2. I plus plus. And we look over here at z and b. They are not equal. Max is still 2. J plus plus. We come here. We look at z and a. They are not the same. Put a 0. Max is still 2. J plus plus. Look at the z and x. They are not equal. Max is still 2. J plus plus. 5 and 4 gives us looking at z and y. So they are not equal. Max is still 2. J plus plus. Now we look at z and z. Those are equal. So array at ij equals array at I minus 1 j minus 1 plus 1. So that's 3. Max is now 3. J plus plus. Now we look at f. Add the 0. Well, since j is, oh, I didn't finish. Now we look at z and e. That equals 0. Max is still 3. J is now 7. We look at z and f. 0. J is 8. Gets out of that for loop. Now I is 6. J becomes 0. Max is still 3. And we look at j being 0. We come down. This becomes 0. Max is still 3. J plus plus. F and B, 0. Max is still 3. J plus plus. F and A, 0. Max is still 3. J plus plus. We look at F and X, that's a 0. And so we've got max is still 3. J plus plus. F and Y is 0. Max is still 3. J plus plus. F and Z is 0. J plus plus. F and E is 0. Max is still 3. J plus plus, F and F are the same. We look at our diagonal, add 1. Max is still 3. J plus plus, we get out of our for loop, and I plus plus. I is now 7. J becomes 0. Max is still 3. And we look at E. And our first one is a 0 because J equals 0. Then we go to E and B. That's a 0. We forgot to increment, so then that's 2. Max is still 3. We go to E and A, 0. Max is still 3. J becomes 3. E and X is 0. Max is still 3. J plus plus. E and Y, 0. Max is still 3. J plus plus. E and Z, 0. Max is still 3. J plus plus. And E and E is equal. So 0 plus 1 is 1. Max is still 3. J becomes 7. E and F, 0. Max is still 3. J becomes 8. We get out of that loop. And we go I plus plus. I is now 8. And 8 is not less than or equal to 7. So we get out of that loop and we return max, which is 3. And we can see in our chart that it is 3 as our maximum longest common substring that we found. And again, this is an O of M times N solution. And it uses O of M times N space.